In this lesson, we'll discuss streamlines, streak lines, and path lines, which are tools to help visualize flow. Here we have a ball that is traveling to the left through a fluid. And now we will show some of the surrounding fluid elements. If we attach our reference frame to the ball appears stationary and the fluid appears to be flowing toward the right, as shown by the red velocity vectors. Streamlines are lines that are tangent to the velocity vectors of the fluid elements. Let's look at the velocity vector of an individual fluid element and decompose the velocity into its y component, lowercase v, and its x component, lowercase u. We will write the ratio of lowercase v to lowercase u and substitute dy dt for lowercase v and dx dt for lowercase u. The dt's cancel out and we are left with dy dx. Rearranging the equation, we obtain dx over u equals dy over v. Had we examined the z direction as well, we would find that these ratios also equal dz over the z component of the velocity, lowercase w. If we know the velocity components as functions of position and time, we could integrate this equation to find the streamline passing through a given point. If the flow is steady, that is, the velocity at all locations in space does not change in time, the streamlines will be constant in time. If the flow is unsteady, the streamlines will change in time. Another way to visualize a flow is to inject dye or smoke into the flow. At time t, we will release a small piece of reddish dye into the flow at location xyz. We will label this dye marker as 1. After a small time delta t has passed, the red dye marker has traveled away from its original location and a small piece of blue dye, named 2, is released into the flow from location xyz. We will use a dashed red circle to indicate the previous positions of the red dye marker. Another time delta t has passed and a purple dye marker named 3 is released. Yet another time delta t has passed and a green dye marker named 4 is released. The dye markers 1, 2, 3, and 4 together make up a streak line, which is defined as a set of fluid elements that pass through a fixed point in space. All 4 dye markers originated at position xyz. If we connect all the points that the red dye marker has passed through, we would have created a path line, which is the path traced out by a single fluid element. For steady flows, streamlines, streak lines, and path lines are identical. However, for unsteady flows, they usually will differ.